Students, in this video we are going to understand the basics of projection of line. So you already know about 9 different position of projection of point. Likewise we have 6 different position for lines. So the first position is called line is parallel to both HP and VP. Now as you can see that in this book, right, this will be your vertical plane and this will be a horizontal plane. So your position will be like that. This will be your VP and this will be your HP. The first position is called line parallel to both HP and VP. It's the position like this. The line is parallel to VP as well as line is parallel to HP. Now you already know we are going to rotate the horizontal plane 90 degree in clockwise direction. So this will be your XY line. So this marking will be your XY line. This will be your vertical plane and this will be your horizontal plane. So the first position is line is parallel to HP and VP. So the front view will be on vertical plane. Now as you can see this from the top view will be in the horizontal plane. So your front view is above the XY line and your top view will be in horizontal plane. So below the XY line, this will be your XY line. So front view will be over here and top view will be over here. Okay, so likewise the position we can draw. So this A dash B dash is your front view and your top view will be like this, A to B. So this will be your top view. So this line will be your projection lines, this two will be your projection lines, right? So this will be your lines A dash B dash and AB. A dash B dash will be your front view and AB will be your top view, right? Likewise we have 6 different position for line. Second position is called line is parallel to HP and perpendicular to VP. So we can place the line like this. The line is parallel to HP and perpendicular to VP. This line is perpendicular to VP. So as you can see that in your front view you can see only a point, right? And this line will be seen in the top view. So we can rotate this like this. So line will be in the top view, right? And in the front view we can see the dots only, right? So we can draw it like this, XY line. So this will be your XY line and your line will be like this, A to B, right? And your front view, now we can draw the projection lines like this. So your front view will become this only, the point. So we can write A dash B dash over here. So this will be the case when line parallel to HP and perpendicular to VP, right? So in top view you can see a line and in front view you can see only a point. Now the third case, line is parallel to VP and perpendicular to HP. So you can place like this. This line is parallel to VP. This is parallel to VP and perpendicular to HP. So your front view will be a line and in top view, which will be seen in the horizontal plane, you can see this, the top view. Okay, the top view will be a point, right? As we have seen in the previous case. So in this particular case, this will be your XY line. So the XY line, right? Your front view will be a line. So that becomes A dash and B dash. Now we'll draw the projection lines. So this will be the projection and the top view will be your A to B, right? So in this case, line parallel to VP and perpendicular to HP. In front view you can see the line and in top view you can see the point only, right? Now the fourth case will be line parallel to HP and perpendicular to VP. Sorry, line is inclined to HP and parallel to VP. So this case will be seen like this. This is the line which is inclined to HP. Say for an example, it is inclined to HP by 30 degree. So the front view will be seen like this, an inclined line in the vertical plane. Now in the top view, now this will be the actual length of the line. Say for an example, this line is 15 mm. So we have to draw in front view this 15 mm line. But while in case of a top view, if you are seeing in a top view, the length of the line, it will be seen as a line only, but the length of a line will be reduced. Like 15 mm line will be reduced to certain extent. So we'll draw the case for that. So this will be your XY line, right? So the inclined line, for drawing the inclined line, say for an example I am drawing an imaginary line, we can call it as locus of A dash because it's a front view. So we are placing this point A dash. Now we know the angle of this particular line, say for an example 45 degree. So we have to draw this line at 45 degree. Let's call it theta equal to 45 degree. The end point of a line B dash, say for an example the actual length of the line, we also call it as a true length. So true length of the line will be 15 mm. So we have to draw this as a 15 mm line. After that, for drawing the top view, we have to draw the projections. So we extend these projections vertically in a downward direction, right? So the top view will be somewhat like this, A to B, right? A to B. Now this length, if this length is 15 mm, obviously this length will be reduced to certain amount, right? So this will be the case when line is perpendicular to HP and parallel to VP. This will be your front view, this will be your top view. Now this top view will also called as plan length because we are seeing it in a top view, and the other name of the top view is plan, and that's why it is also called as a plan length. Okay, and this theta is the called true inclination, actual inclination of the line, theta, and this will be the actual line or actual length of the line, and that's why it is called as true length, TL, that will be true length. We'll see that in the next session also. Theta, TL, true length, and this will be your plan length. Now see the next case, line inclined to VP and parallel to HP. So that case will be placed like this. This line is inclined to VP and parallel to HP. See, this is parallel to HP. So this inclination can be seen in the top view. So if I'm making the top view, okay, so this top view will be seen at the bottom. Okay, means if this is the XY line, in below the XY line you can see this angle of the particular line, and in front view you can see a line only, right? So in top view this length will be actual length. In top view the 15 mm length will be seen, but in front view the length will be differ from the actual length. So how we can draw that? So you have the lines, XY line. So you know the angle of the line. Say for an example this is line, and if I'm taking certain point A over here, now this is the top view and that's why I'm writing A only. If you know the angle, say for an example we call it as phi. Say for an example phi equal to 30 degree. Okay, so a 30 degree point. Now you know the length of a line, true length equal to 15 mm, so 15, and after that I'm like keeping it B. So A to B is the true length, actual length in a top view, right? I'm drawing the projections for that. Okay, and from that top view, consider this will be your front view. So A dash to B dash, right? So this will be your actual length, true length 15 mm. This will be your actual angle or true inclination, which will be 30 degree. We call it as phi 30 degree, and A dash B dash. Now the other name of the front view is elevation, and that's why this length will be called as elevation length, EL. We'll call it as EL, elevation length, right? So these are the 5 different cases.